Hello, good evening again. Welcome back to JBTeguihanon Engineering and Chemistry Tutorial. Please subscribe to those of you who have not yet subscribed to my channel and hit the notification bell so that you will be updated every time I have a new video. Okay, let's continue our study of refrigeration system. So we are going to review atmospheric pressure. Okay, atmospheric pressure. This guy here, atmospheric pressure. Okay, this one. So, yeah, the sensation of being underwater. So, being underwater and feeling the pressure of water is familiar to many people. The Earth atmosphere is like an ocean of air that has a weight and exerts a pressure. The Earth's surface can be thought of as being at the bottom of this ocean of air. Different locations are at different depths. For instance, there are sea level locations such as Miami, Florida, or mountainous locations such as Denver and Colorado. Okay, and then the atmosphere pressure at these two locations are different. For now, we will assume that we live at the bottom of this ocean of air. Okay, the atmosphere we live has a weight just as the water does, but not as much. Actually, the Earth's atmosphere exerts a weight or a pressure of 14.696 psi at sea level. This is known as standard condition. Okay? So, at the atmospheric pressure, we can measure it through the instrument called barometer. It is a glass tube with 36 inches long. It's closed at one end and filled with mercury. Okay, so this is it. In figure 1.20, mercury, Hg, barometer. So what do you have here is you have mercury inside. This is the red one. And this is of course a tube. And this is the mercury. And you have a mercury paddle. Once the atmospheric pushes down the mercury, this red one goes up to this height, 29.92 inch. That is actually the measurement. Okay, so we'll read it. So the mercury will try to run down. It is then inserted open one side down into the paddle of mercury and held upright. The mercury will try to run down into the paddle, but it will not run down out. This is because the atmosphere is pushing down on the paddle and the vacuum is formed on top of the tube. At sea level, the mercury tube fill 29.92 inch when the surrounding atmospheric temperature is 70 degree Fahrenheit. So yeah, we have already discussed in the figure 1.20. So in figure 1.20, this is a standard that is used for comparison in engineering and scientific work. If the barometer is taken up higher, such as a mountain, the mercury column will start to fall. It will fall about 1 inch per 1,000 feet of altitude. When the barometer is at standard condition, the mercury drops. The weather forecast will talk about low pressure system. This means that weather is going to change. Listening closely to the weather reports will make this term more meaningful. Okay? So, in figure 1.21, we have here, we have here figure 1.21. When the mercury barometer is placed in a closed glass jar, this is a closed glass jar. You have a vacuum tube, this guy here. This is your glass bell jar. You have a mercury at the bottoms, and then vacuum pump to remove the atmosphere. Okay? When a mercury barometer is placed in a closed glass jar, known as bell jar, and the atmosphere is removed from the jar, the column of mercury drops to the level paddle dish. So it will be like level. Okay, it will be it will going down, and eventually it level to this height here. All this what you call that, mercury paddle. Okay, so yeah, so the mercury, let's read this. The mercury in the column has a weight, counterweights the atmosphere pressure of 14.696 psi at standard condition. At a pressure of 14.696 psi, then is equal to the weight of the column mercury, 29.92 inch high. The expression in inch of mercury or inches of mercury has become an expression of pressure and can be converted to pound per square inch. Guys, this is very important conversion. So take note of this. 1 psi is equal to 2.02 inch mercury. So remember this. We need conversion here. Okay. That has been taken from this. 29.92 divided by 14.696 is equal to 2.2036, and it is often rounded off as 2. Okay, and that is actually 30 inch mercury divided by 15 psi, so rounded off value. So another type of barometer is the aneroid barometer. This is a more practical instrument to transport. Okay. Atmospheric pressure has to be measured in many places, so instruments other than mercury barometer had to be developed to healed use. Here is the this instrument in figure 1.22. An aneroid barometer uses a closed bellow that expands and contracts when atmospheric pressure changes. This bellow here. Okay, so that's all for now. Thank you for watching. Please subscribe to my channel, JBTeguihanon Engineering and Chemistry Tutorial. Bye for now. God bless.